This is the review for integration. So in this video, I'm going to go through all the things that we need for the test tomorrow for on integration, on basic integration. So what I'm going to start off with is I'm going to start off with the formula that you need to memorize in order to quickly integrate. And that formula is, well, first off, you'll be given something like this. Oh, let me get my pen out. F of x equals x to the n. So let's say that's your formula. The n can be anything. So I'll give you an example. This can be like f of x equals x squared, right? And what you're trying to do is you're trying to integrate that in order to find the formula to plug into. And I'll show you how to plug into that later when I do later examples. But right now, I just right off the bat, you can't really do much else unless you know this quick rule for integrating. So what it is you take the n here and you add 1. So it's x to the n plus 1. And then whatever this value is, you divide it by n plus 1. So just to see that again, you have x to the n. That's your normal f of x expression. So you could also say y equals x to the n, because f of x and y are the same thing. So you end up with f, not f of x, whatever. If you're trying to integrate the f of x equals x to the n, you end up with x to the n plus 1 over n plus 1. So you're adding 1 to the exponent here, and then whatever that value for the exponent is, you're dividing by. And I'm sorry if you hear my dog in the background. He just won't be quiet. So now I'm just going to go through a few examples just so you know how to use this. So we have our equation down there, f of x equals x squared. I'm going to leave this here just so we know. So what we're looking to do is we're trying to figure out what n is. So we have our f of x, so our n would be 2. Because when we put it into that format, we see x to the n, what lines up? It's the 2. So we know that n equals 2. So what we can do is we can add 1 to that. So 2 plus 1 equals 3. So it's x to the third. But then we have to divide by this x plus 1. And what did we say x plus 1 is? It's 3. So we end up with x to the third over 3. So it's x to the third over 3 is how you integrate the x squared equation. So let me just give you another couple of examples. If you had something like x cubed, sorry, f of x equals x cubed plus x, what you do is you'd follow the same steps, but this time you would just add them. So we're going to add 1 to this. So 3 plus 1, it's going to be x to the fourth. Because you're adding 1, like I said here, that's the formula. All you're doing is you're plugging into that formula, x to the fourth, and then we're taking whatever this value is, and we're also dividing it. So we have the 4, so it's going to be x to the fourth over 4, or 1/4 x to the fourth. But we can't forget about this last part because we're also adding the x. So what is this really? It's really x to the first. So it's going to be x to the first. It's going to be 1 plus 1. So it's going to be x to the second over whatever that 1 plus 1 is, so that's 2. And that's our final expression for what the integral is of x to the third plus x. Just a couple more examples that get a little more complex. Hopefully you understand that. Really all you're doing is you're plugging into that formula that I put right here. That's definitely something that I would memorize if you don't know how to do this, because plugging into it just makes it a lot easier. So let's say you're given something like f of x equals 2x squared plus 4x. Okay. So how would you integrate that? All you would do is you would pull the 2 out, right? You see this 2 in front? All you would do is pull it out, throw in some parentheses because they never hurt, and then follow the same procedure with this x squared. You do x to the 2 plus 1 because you're adding 1 like we did here. So that'd be x to the third. And then we divide by that 3. So it's like that. And then for the 4x, like we did with the 2, we're going to pull the 4 out. X to the 1 plus 1, since this is a 1. X to the 1 plus 1, so it'd be x to the second. So x squared over 2. And then obviously this can be simplified to 2x cubed over 3 plus 2x squared. Right? Because this cancels out, and then this goes on top, and then this stays on the bottom. So that would be our final integral expression. Any more that I wanted to go through? Not really for that, but I'm going to go through the other types of integration. So now we know how to integrate just with regular variables. So now I'm going to go to the special cases. So you'll have something like f of x, and I'm really sorry that you hear my dog. He just not stop barking. F of x equals the cosine of x. And you're trying to find whatever the derivative of, sorry, not the derivative, the integral of that is. And that would be the sine of x, right? Because if you take the derivative of this, you can go there. So here's the cycle. You integrate to get this, and then you can take the derivative. One second. Sorry about that. So that's the cycle. You can take the integral, and then you can take the derivative of whatever that integral is, and then you can get back to the original value. So that's just a quick check. This all comes from your whatever you memorized to be your 5 special exceptions for your derivatives. That same thing just carries over to integrals. There's nothing really that I can help you with if you don't have those memorized. You kind of just have to have those memorized. I'll just off the top of my head, I know you need to know this one. So this would be 1 over x. This would be cosine of x. This equals negative sine of x. What else is there? There's e to the x. And then there's a 5th one, but I'm blanking on it. Comes back to me, I'll bring it up. But all you have to do is these are the rules that we learned for take the derivative. So when you go this way, you're taking the derivative. And like we said, you can go backwards and take the integral. So if you're given a value like this, 1 over x, right, and you want to find whatever the integral expression is for that, all you do is you go backwards on those keys that we learned, and it's the ln of x. Same thing for cosine of x, you go backwards to sine of x. Negative sine of x would be the cosine of x, and then e to the x is just still e to the x. What would be that expression? Oh, it's the tangent squared. X, sorry, tangent, not tangent squared. Tangent equals secant squared of x. Yeah, that's the expression. So then you derivative, integral. Simple enough. Those are just things you should memorize. There's no way to logic them out. You just have to have that memorized, that those are the 5 special exceptions. There's actually a decent amount of memorizing that you should be able to do for this test. And it would just help you out a lot. So now that we basically know how to do the quick methods of integration, I'm just going to look at a few more examples that I have down here. So if you're given something like the integral of x cubed plus 2x with dx, it's not too important for this test if you know what this is, but that's the form that all integrals are going to be written in. It's going to be the integral sign from a to b. In this case, I don't have a to b here because it's not important, at least for the problem. And then you're going to have whatever your expression is. So it could be like x squared or whatever. And then with respect to dx, that's for us, this dx will change eventually. But for now, that's the format that's going to be written. So all this is asking us to do is find the equivalent integral expression for that. So like we did before, we're going to follow the same rules. We're going to take this expression in the middle here. So x cubed plus 2x. And what we're going to do is we're going to add 1 to this. So we're going to get x to the 4th. And then we're going to divide by this value over 4. Plus, pull out the 2. You can pull that out in front. This is x to the 1. So it's going to be x squared over this value, 2. These 2's cancel out. And you're left with x to the 4th over 4 plus x squared. Okay. That's your final expression. Oh, wait. No, it isn't, because you have to add c. Okay. That's a very important part. when you don't have from A to B here. If it was from A to B, then I could just leave that C off because it doesn't matter. But if it's not from A to B, then you have to add the C. So if I just left it like this, it's wrong, because if you think about it, if I were to take the derivative of that expression, it could get me to that to this expression, but so could this. So the reason that we're putting C there is just to say that when taking the derivative of it, it's just going to drop out, but we don't know what it is unless we're given more information. Like, I'll give you an example. If you have x squared plus 4 and you wanted to take the derivative of that, so this would be your f of x, your f prime of x, which is the notation for a derivative, would be just 2x because this 4 gets dropped off. So when you're trying to integrate that 2x, you end up with losing that c value if you don't carry it over. So if I gave you f of x equals 2x, so if I just gave you 2x and I said to integrate it, you would get, since this is 1, it would be 2 times x squared over 2. 2's crossed out, and you just are left with x squared. But the original expression we had was x squared plus 4. So that's what the c is. X squared plus c. The c could be any value, we just don't know what it is. So that's just us acknowledging that something could have been lost if it was just a constant. That c only has to be included if, like I said, there are no a and b values. If there's a and b values, I'm not going to go through the math here, but it does drop out. For the most part, though, the way that we're doing it, he's not going to include a and b values, so you have to remember c. I'll write it in big capital letters. Have to have c. Otherwise, that's a wrong expression. I can't emphasize that enough. Okay, another example, a couple more examples. Okay, we have the integral of cosine of x dx. Okay, so that's a special case. We know that the cosine of x is one of those 5 special cases. So how do we do that? What we can do is we can write out the special case that we know it is. So it's going to be taking derivative of what gets you the cosine of x. It would be the sine of x, right? Because if you take the derivative of sine of x, it's the cosine of x. Don't get it confused with this. Cosine of x equals negative sine of x, right? Because remember, when you're going from left to right, this is taking the derivative. This is taking the integral. Sorry, not that. This is taking the integral. So when you're going from left to right, it's taking the derivative. Right to left is taking the integral. So this is not the right expression. We're looking for this one because we're trying to integrate the cosine of x. So we find that cosine of x integrates to become the sine of x. It helps to write out the full expression like this. Because if you write it out and you know that you're trying to integrate the cosine of x, you won't end up with the sine of x because that's wrong, because that's how you take the derivative of it. Just a little hint if you're struggling with that. So the final answer would be the sine of x. And now a big red buzzer should be going off in your head, because like we just said, when there's no a and b here, right, there's none of that, you have to include the c. So now that's the right expression. Sorry, my dog's barking. So now that is correct. Sine of x plus c is how you integrate the cosine of x. Because think about it, if we took the derivative of this, just one second. If you took the derivative of this, then the c drops out. So you took the derivative of this, this would be the derivative. And this would leave you with the cosine of x. Anyway, the c would drop out. But for our answer, we have to include the c to acknowledge that there could have been something there. Okay, so we're going to go on to our last just example for that. These should be easy points once you understand how to do this. Dog's really barking. Someone's trying to quiet him. X minus 1 over x dx. Okay, 1 second. Sorry about that. So we get or we're trying to find the equivalent integral expression for that. So we have x minus 1 over x. So this is x to the first. We can follow our regular rule from that I've started the video off for. 1 plus 1 is 2, so it's x squared over this value. So it's x squared over 2 minus 1 over x. How would we find the equivalent integral expression of that? Well, if you remember those 5 rules that I wrote, actually this was one of them. The ln of x equals the 1 over x when you're trying to take the derivative. So then when you're trying to take the integral, you end up with the ln of x. And then again, we have our plus c. Plus c, plus c, plus c when there's no b, a and b. Kind of rhymes. The big thing here is just remembering that 1 over x is the equivalent of ln of x when you're trying to take the integral, and not trying to go like x to the negative first and then add 1. Because if you wrote it like, let me just show you, 1 over x equals x to the negative first, right? You should all know that just because it's in the denominator, because this is x to the first, and since it's in the denominator, oh, sorry, x to the negative first. Since that's in the denominator, it becomes negative. So then when you follow the regular rules and try to add 1, you get negative 1 plus 1, which is of course 0. And then you get x to the 0, but then you have to also bring this down to the bottom. So you get x to the 0 over 0, which I have no idea what that would mean. And that's just a sure sign that you're wrong. So just make sure you know those expressions. And don't forget your plus c's. Okay. We're going to go on to the next part. And the next thing that I want to talk about is Riemann sums formulas. So there's 3 important Riemann sum formulas that you need to know. And the first is this one. Hold on. Sorry. So the first one that you want to deal with is this one. Or sorry, there's 3 different Riemann. That's a terrible summation sign. There's 3 different Riemann sum formulas. That's also a terrible summation sign. There's 3 different Riemann sum formulas that you need to have memorized. The first one is the formula for just regular k. So that would just be 1 plus 2 plus 3 plus 4 plus 5, so on. So that would be where k equals 1 to n. And then the equivalent of that is n to the n plus 1 over 2. It's totally fine if you don't understand it right now. I'm going to explain it again in a little bit. But I just want to have these written down just so you have them to write down as well. Okay, this is the second one, and then k equals 1 to n, and then this is k cubed, and all it is you're taking the first expression that I wrote up there and squaring it. Those you definitely have to memorize. They will be on the test tomorrow, and you have to know how to use them. So I'm just going to give you a second to write it down while I look over my notes, and we'll go through a few examples. One thing that I would like to note while we're looking at this is that for all of these, k equals 1 to start. There will be some cases where if you're given something like this, let's say k squared, right, from n to k equals 3, right? That does not match up with the formulas that we gave. So the equivalent expression of that would be, it would be the summation of k squared from k equals 1 to n minus the summation of k squared from k equals 1 to 2. You don't go up to the 3. That's a big mistake. you go one below K. So just looking over something here. So that's what you would do if it doesn't start at one. I'm not going to go through an example of that just because it takes a really long time. Just know the general rule. And then besides that, that should be pretty easy. It's just straight plugging into formulas. I'll go through one or two examples, but not including that. So just have that memorized that if K does not start at one, what you have to do is you have to take two different summations and you have to subtract them. So hopefully you have those expressions written down for Riemann sums formulas, because I'm going to need this space in order to do the work. Okay, we have, I'll do one example. Let's say we have our summation from K equals 1 to 30, and the expression is 3K. Okay. And what we wanted to do is we wanted to figure out what that would be equal to. Well, we know that it's not K squared, it's just K to the first, which would be our first expression. And what we can do is we can pull this 3 out in front like we did for the other expression. This value is what our n value is. So we're going to do 3 times 30 plus 30 plus 1, or sorry, times 30 plus 1. That would be 31 over 2. And that's our answer. I wouldn't simplify this. The only thing I might simplify is 31. But besides that, you can leave it. Yeah. The big thing for this is just being able to pull out that leading number and not getting confused of what to do with it. That's actually a pretty simple example though. So I'm going to do one more complicated one, and then we're going to move on to the next thing. Let's say you were given something like this. And what are you going to do for this? Because obviously you have two different K values, and yeah, luckily there's no numbers in front. Actually, you know what? I'm going to throw a 2 in there. So now we have to put a culminate all of the things that I've said. So all you're going to do is you're going to pull this number out in front. You're going to get the 2 times, look at your K squared formula. K squared, it would be, well, first of all, this is n. It's 15 times 15 plus 1. So it would be 16 times 2 times 15 plus 1, because it's 2n plus 1. So it would be 31. And a quick check is that these two numbers add up to that number. So it'd be 15 plus 16 equals 31, all over 6. And then we want to subtract K cubed, and the expression for K cubed is, it is n times n minus n plus 1, so it's 16 over 2 squared. And that's our final expression. You don't have to simplify that. I would just leave it like that. Sorry that it's all over the place. And I can't even get to my eraser. So now I'm going to move on from that. I'd say the biggest things to take away from that is that if you have two separate Ks, you just substitute in the formula for the K and you carry on from there. If you have a number in front of the K, you just bring it out in front like we did with the other examples. And one of the biggest things is that if K does not start at 1, you have to subtract, like I gave the example earlier. You have to subtract one summation from the other. So you should have a summation minus summation. And then the summation you're subtracting does not go all the way up to the K value. It's 1 under the K value. So that's going to be one of the questions on the test tomorrow. So you should be familiar with that. Okay, so I'm going to just do a couple more examples because this video is getting really long. Approximate the area. Let me find a good example. I'm not going to go through. I guess I probably should. I'm going to start with the chart problem. We have 6 boxes. Let's see, we have 2, 5, 7, 8, 11, 13, 5, 8, 13, 12, 8, 5. Okay. Let's say you're given a chart like this, nothing else, and you're asked to approximate the area using left endpoints from 2 to 13. So you're looking for lefts from 2 to 13. How would you do that? Well, let's imagine we had a graph here. Make it just an x squared graph. And we wanted to go from 0 to 3. Okay, and we wanted to do left endpoints. This is 3, and this would be 1 and 2. We wanted to do left endpoints. So obviously, we would look something like this. Okay, starting at the left, go up the left side, and then you draw the box over. So the first step when you're giving a problem like this is you want to find the difference in between these. So it'd be 3, difference would be 2, difference would be 1, difference would be 3, difference would be 2. First step, anytime you see a chart problem, find the difference. And then since it's left endpoints, what you want to do is you want to start with the f of x value that is on the left, actually. That's a good way of remembering it. Let me just double check with that. Yeah, so if you're given a chart problem like that, 1 second, I just want to look over something quick. Yeah, so what you're going to do is you're going to take these values that we have. We are 3, 2, 1, 3, 2. And then a good way is that if you're thinking that you're starting from the left, all you do is you draw arrows down to the left like this. And that's your corresponding f of x value. So when you're writing it in and you're doing your boxes, what you do is you do the 3 times 5, right? Because the 3 and the 5 match up. 2 times 8, so it would be plus 2 times 8. 2 times 8. And then so on. You do 1 plus 13 plus 3 plus 12 plus 2 plus 8. And notice that we don't use this. And that makes sense because if we look at our graph on the right here, we don't actually use this endpoint. Because if you're only doing lefts, you're not using that right endpoint. So that should be disregarded for this matter. What else? And obviously, if you're doing right endpoints, it would just be the opposite. You wouldn't be going to the left. Oh, I reversed the number there. You wouldn't be going to the left on your chart problems. You would be going to the right. This is for right endpoints. And that makes sense because if you look at this chart, if we wanted to go from the right endpoints, it would be like this. And we're not using this 0 endpoints. You see? If that's confusing to you, memorize that when you're given the chart, you take the difference between the 2 x values, and then you multiply that difference. If it's a left endpoint, you multiply that difference by the number on the left, like that. Or if it's a right endpoint, you multiply it by the number on the right. Okay, simple enough. Now, what if I asked you to do middle, go up the middle rather than use left or right endpoints? Let me just try to clean it up because I made a little bit of a mess. And I'm erasing a lot more than I wanted to. Whoops. If I wanted you to go up the middle, then all you would do is instead of taking the difference between these two values, you're going to skip that and you're going to skip one value in between and you're going to go with the difference between 2 and 7, which would be, sorry, I'm going to erase these values, which would be 5. And then you're going to skip again. Difference between the values are going to be 7 and 11. It's going to be difference between the values are going to be, that's why there's a problem. I'm just going to add one more column because if you're asking for midpoints, it should be a odd number of rows. Oh, I just realized a mistake. I had 2 to 13 here. That should have been hard bracketed. I don't know if that was soft bracketed. It looked like it was when I was erasing. So let's say I just add another row in here. And I said it was, I don't know, something like, oh, this should be 13 anyway. So let's say we had, sorry, I had to take care of something. Let's see, another value like this. So the difference, we would just follow the same thing. Skip over the 8. Difference between 11 and 7 would be 4. The difference between 11 and 15 would also be 4. So now that we have the differences like that, where we're skipping over one, all we're going to do is we're going to take that difference, we're going to go right down the middle. Then we end up with 8, 12, and 5. That could be a little confusing. Just know that we started at the left, skipped over one, went to the next one, found that difference. That's how we got the 5. And then we went straight down and you multiply it by the 8. So you end up with 5 times, sorry, not F. 5 times 8 plus 4 times 12 plus ... The ... would obviously be this, but I just ran out of room on the bottom right. So the steps for middles, this is middle now, are that if you want to just memorize that. You skip over one, take that value, and then you go straight down the middle, and you multiply by that value. And that's how you find the area if you were to use middle points. Another thing that I would like to note is that left, sorry, never mind, actually, I can't say that. I'll go over that on that. Okay, so if you need to memorize those steps because you don't understand it, pretty self-explanatory. Left, you go to the left. Right, you go to the right. Middle, you go to the middle. The only real difference between them is that when you're taking the middle, you have to skip over, or when you're taking the middle length, rather than going up a left or right side, you have to take the, or you have to skip over the X values rather than going the difference between each of them. You take the difference between every other one. So last of our 2 things that we've touched on is finding the area using inscribed and circumscribed rectangles. Okay. Wow, this is going to be a longer video than I meant for it to be. So if we have our equation, something like y equals x minus 2 squared plus 1, and we wanted to use 4 inscribed circles or 4 rectangles inscribed. And we wanted to go over the range 0 to 4. Let's just first draw out a picture, just because it's always good to draw out a picture. So it's going to be 1 unit up, and it's going to be 2 units to the, yeah, it's going to be 2 units to the right. Okay. So now that we have our graph, what can we do? We can try and, well, I'm just looking at something here. We can try and draw it and sketch it just to understand what it might look like. So it's going to be an x squared graph. I'm not sure if that's exactly how it looks, but it could be close. So we have our 0. This is going to be 2 because that's where that minus 2 comes from. 1, 3. Okay. So what do we do here? We talked about in the chart problems. We know that the length of our bases is going to be 1 because we said that there's 4 rectangles and the difference between each of these is going to be 1. Oh, actually, a good formula to memorize is that base length equals a minus b over n. That's going to be more so used in the last example that I give, but you can plug into it now. So your a would be 1, your b would be 0 over n, which would be 1 rectangle. So it'd be 1 minus 0 over 1. That could be confusing, but you could also use this. This is your a, this is your b. So you do 4 minus 0 over the 4 rectangles over the 4 equals 4 over 4 equals 1. Okay, so that's just how I got the length of the base, just in case anyone was confused. I would memorize that formula. It's good for the, like I said, the later example that we did. So now that we have our graph, we want to use inscribed rectangles in order to find the area. So if it's inscribed rectangles, do you think that it would be outside or do you think that it would be inside? Obviously, that probably gives it away. Inside, inscribed. So you want the rectangles to stay inside the curve. So for this one, it's going to be a right going up the right. This one's also going to be going up the right, but then this switches over. So now we're going from the left endpoint. And then again, we're going to the left endpoint. The main thing of an inscribed equals inside. You should never be leaving or going above the curve. Notice how every rectangle that I have here is below the curve. It's inside of it. Okay. So now what do? What we can do is we can use that base length. We can do 1, or we can find the area of each rectangle individually. We can do 1, pull that out, times f of, we're going to use f of 1 because we went up from this side, times f of 1 plus f of 2 plus f of 2 again plus f of 3. And that could be confusing where I got that from. This is just the base length. And then what I did is, so obviously the area of a rectangle equals the length times the width. We know that the width equals 1. So all I did is I pulled that out in front, right there. So now we just got to find what the length is, or what this height is of the rectangle. And what is the corresponding value? Well, it would be f of x. But f of what? It would be f of whatever side you're going off of. So for this, we're going off the right side. And since the right side has an x value of 1, this is our x-axis, an x value of 1, the f of x value would be f of 1. When we're going up this side for this rectangle, it's going to be f of 2. When we're going for this rectangle, it's still going to be f of 2 because this side is the same thing. It's shared side. And then we're going for the height of this rectangle, it's going to be f of 3. Okay. And then obviously what you would do is you would take these values and you would go and you would expand it out and plug the 1 in. So you would go like 1 minus 2 squared plus 1 plus yada, 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 yada. And you would plug in each of these values into that equation. And then that's how you would find your final answer for your inscribed triangle, inscribed rectangle. Okay. So now let's say I said circumscribed rectangles. Well, it would be the same thing. It'd be the same thing, but instead of doing the, let's see if I can erase this. Not doing too much damage. Yeah, that's pretty good. So it'd be the same thing, except for the fact that when we're going, we want our rectangles to be outside of the curve. So circumscribed equals outside. And what does that mean? It means unlike when we were inscribing the rectangles, we want them to be outside. So we're going to start here, outside. Start here, outside. Start here, outside. Start here, outside. Okay. And you see how this whole portion is outside? That's a dead giveaway that this is how you should be properly circumscribing the rectangles. Each of the rectangles should have a little bit that's outside of the curve. Okay, so now that we did that, we can follow the same procedure. We know that our base is 1, but this time we're trying to find the length. Would the length be f of 1 or f of 0? Well, if it was f of 1, you'd be inscribing it at that height. But since it's circumscribed at this length, right? Because this is the f of 0 value, you're going to use f of 0. And then you want to add that to, let's see, would it be f of 1 or f of 2? Well, if it was f of 2, it would be like this. So obviously it's f of 1. It would be f of 1 plus, excuse me, plus f of 3. Because like you can see, that's the length, not the f of 2. Because f of 2 only goes up to here. And then finally f of 4, because that's the height. So then what you would do is you would plug into the formula. You get 1 times 0 minus 2 squared plus 1, yada, 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 plus whatever. Then you would plug in all these 3 other values. And you would add them to your arithmetic, and that's how you find your area for circumscribed rectangles. I'm running out of time in this video, so I can't go through all the steps. Hopefully you're familiar with the arithmetic. Otherwise, there's other videos. I'm sure there's one where I teach you guys how to add. It gets really monotonous. That's one of the main reasons why I'm also not doing it. So the last thing that I want to talk about, and this is another reason why I didn't want to do it, because I wanted to save my energy for this big one, is that if there is infinite rectangles, and this is going to be the big one tomorrow. Let's say I'm giving you an equation like, I don't know, let's say f of x equals 3x squared minus 2x, and you're looking from the range from 0 to 2, and you're looking for n rectangles. Wow. This is going to be really difficult to do on this, just because I'm looking at my notebook here. It takes up a full page in my notebook. So going through this is going to be a really messy process. So I hope that everybody stays with me. So I'm just going to pull up a quick graph of what this equation would look like, just so I can visualize it to you guys. The equation looks something like this, or if you have a graph, it dips down like this, okay? And we're looking over the range from 0 to 2, okay? But I would draw in triangles, except for the fact that it's going to be, it actually dips down a little bit like that. I would draw in triangles, rectangles, except for the fact that there's going to be n rectangles. Oh, before I forget, I forgot to mention on the last example how you find trapezoids. So what you would do is trapezoids, like if it asks you for trapezoids, how to find the area using trapezoids as opposed to inscribed or circumscribed, it equals the inscribed area plus the circumscribed area over 2. It's the average of the inscribed and circumscribed area. That's important to know because there'll be a question that I meant to touch on that. I just completely spaced on that. Okay, so now that we're looking at our graph, n rectangles means that there's going to be infinite rectangles. So if you could just imagine it like rectangles, like all throughout this, and I can't even come close to infinite rectangles, obviously, because that's more of a theory thing. So the main way that you do it is you use that formula from before, where base equals b minus a over n. Your b is 2, your a is 0. Your base would then be base equals 2 minus 0, so I'm just going to leave it as 2 over n. And we can actually use n this time because we have no specified number of rectangles. Before we had 4 rectangles, so n was just 4. This time we have n, so we're going to leave it as 2 over n. So that's our base width. So obviously area of a rectangle equals length times width. So since the base of all the rectangles is going to be 2 over n, what I can do is instead of writing that over and over, I can just pull it out. Let me clear some area here because I'm going to need it. I'm actually going to erase this graph too. What I'm going to do is I'm going to pull that out. Area is approximately, this is important, use the approximately symbol. Don't get mad at me, I'm using it. You should too. 2 over n. That's our baseline. Like I pulled it out before, you can pull it out here again. Our base width times the f of our first value plus our f of our second value plus our f of our third value and so on, like we did in the last one. But the trick is that we don't have like f of 1 plus f of 2 because we don't have x values like that, but we do have base widths. So what we can do is we can follow this idea that the first one is going to be the f of this base width. Okay, and then we're going to just keep adding on the base width. So it's going to be f of 4 over n plus f of 6 over n, so on, so on, so on, till you get to f of 2n over n. A good way of double checking yourself is that if this was arithmetic, these two n's would cancel out and you're left with the 2, which is exactly what our b value is. Now, let me explain this a little bit further because that's probably confusing to you guys. If you guys have a graph and you're given something like this and you want to find this value, and you know that each of these is 2 over n, 2 over n, 2 over n. Like we had before, where if this is 0, when trying to find this length, all you have to do is you have to take the x value for this. So this value would be 2 over n. This value would be 4 over n. This value would be 6 over n. So you take that x value and you plug it into the function. Okay. And what that would do is it would give you rectangles like this. But when they're so small, that little error does not matter because they're infinitesimally small. So I hope you understand that since each of these is 2 over n in length, this is going to be 2n. Then you're going to be adding another 2n, which is 4n, another 2n, which is 6n, and so on, so on. Finally, until you get to 2n over n. That's kind of just something you have to memorize, is that it ends in, what's a good way to memorize it? A good way to memorize it is that it ends in b, I'm going to give you a formula, b and yeah, it would be bn over n, where b is that value that we have here. So it'd be 2n over n. That's the formula, just in case you're looking for something to memorize. Because we love memorizing, don't we? Yay. So I'm obviously not going to have room to go through all of these questions or all of these steps, but I'll give you the gist of them. So our next step would be a of 2 over n times, and then all we're going to do is we're going to plug in these values into the equation like you would do if it was f of, oh, my dog's barking again, f of 3, like you would do, you would plug the 3 into the equation, but instead of 3, you're going to plug 2 over n. So you end up with 3 over 2 over n squared minus 2 times 2 over n plus 3 times 4 over n minus 2 times 4 over n. And I would keep going with these other two values. I just don't have room. So that's why I'm leaving these dots. I personally don't have room. You should do that on the test for at least these 4 values. It should always be the first 3 values plus the last value. So ultimately what that's going to leave you with, sorry, this should be squared. Ultimately what that's going to leave you with is something that you should rearrange. Oh, not equals. See, I almost did it. Something where you should pull out these squared terms and you get left with 3 times 2n squared plus 3 times 4n squared all the way to the 3 times. So it would be that squared, it would be 3 times 4n squared over n squared. And then we want to, subtract minus 2 times 2n minus 2 times 4n, and then so on. Oh, sorry. Oh, how do I get rid of this? Collapse. Nope. How do I get rid of this? Escape me? Nope, I won't do that. What do I do here? Oh, there we go. F of 4 over n. And again, you should keep going. I just really can't. I'm trying to give you guys a just because that way, if you don't understand, you have at least an idea. So since we see that all of these terms have 3's, we can pull it out, and we can also pull out the first term. I know that's not the way you should do it because you should be looking for a greatest common denominator, but this first term will always be the greatest common denominator. So what I mean is that your area will equal the 2 over n times 3 times 2 over n. Sorry, I actually made a mistake. You shouldn't be pulling that out yet. What you should be doing is you should pull out, you can pull out the 3, but you want to distribute the squared in first. So you want to do 3 times, so it would be 4 over n squared plus 16 over n squared plus, I know I don't have the word for it here, but this would, the 6 over n would leave you with 36 over n squared, plus the 16 n squared. Sorry, no, that would be 4. I don't know why I distributed the squared to sums and not others. So I'm actually going to fix that just to not be confusing. This should be 2n over n squared. Then this squared gets distributed in, and you get left with 4n squared over n squared minus 2, you have your 2's, times 2n plus 4n plus 6n plus 2n over n. If you're confused, I'm just going to go through all these steps one more time just to explain them to you. So here what I did is I found my baseline or base width using that equation. Base equals b minus a over n. B equals 2, so 2 minus 0 equals 2 over n because there's n rectangles. If I keep saying triangles, I'm sorry, I mean rectangles. So then what we do is we take that the x values, which would be the base width to start off with, because when you're doing n rectangles, you want to take the right side. You want to take the right side. So you start with the base width and you keep adding it on. So that's why we have 2n, 2 over n, and then we add a 2 over n. So 2 over n plus 2 over n equals 4 over n. And we add another 2 over n, we get 6 over n, and then so on all the way until 2n over n. A good way to check is that these n's cancel out. So you like this, and you would be left with 2. So then going on, what we can do is we can take this value we have in here for f of x, and we can plug it into the function. And that's what we did here. We get 3 times this value squared minus 2 times the value plus 3 times this value squared minus 2 times the value, and so on for the 4 values that I have here. Then what I did is I took the terms that were squared and I put them on one side. So these are all the square terms. And then I took the terms that were just raised to the first power and I put them on the other side. So then what I was able to do is I was able to pull out the 3 and pull out the 2. And it left us with this expression for the squared side, and it left us with this expression for the raised to the first side. So now what I'm going to do is I'm going to erase all this. And we got a lot more to go. Not mores. It's good grammar. I'm sure it was a way to just erase this all, but fortunately there's not. I'm actually going to erase this integration. You don't need that. You don't know that we're integrating right now. Good luck for tomorrow. kidding. Hopefully everybody knows that this is integration. Okay, so the stuff that we were left off with. Shoot, I kind of wish that should have wrote that down. You know what? I think I have an actually written down something. Yes, I do. Never mind. Okay, so remembering the expression that we had from before, what we can do is we can take out the first, the greatest common factor, which would be 4 over n squared. So then I'm going to rewrite the expression. The area is about the 2 over n, which is our base width, that's not changing. And then we have our 3 times our greatest common factor, which would be the 4n squared. Pull that out, and then what we're left with is the 1 plus 4 plus 9 plus n squared. Do the same thing for the other side, and we can pull out the 2, I believe it's the 2 over n. It should be a minus sign, minus 2 times 2 over n times 1 plus 2 plus 3 n. Okay, it's really sloppy. I'm sorry, I don't have a lot of room on the board that I'm writing on, but I'm trying to do the best that I can for you. So I'm just going to rewrite this one more time. And the biggest thing to remember is that this has to get distributed to both terms because these are both in parentheses. So you end up with the area equals 2 over n times 3 times 4 over n squared times 1 plus 4 plus 9 plus n plus ... Because remember, there's infinite terms in between there, minus 2 times the 2 over n times another 2 over n times 1 plus 2 plus 3 ... plus n. Okay. Let's see where I am here. Okay, I believe we're in a good spot for now. Let me just double check one more time. Yeah, so we're in the right place here. So now the next step that we would do is we would figure out which sequence we have for these, and we would substitute the Riemann-Sums formulas in that we were doing earlier. So a good tell for this is the last value. So we see that the first one would be n squared. That's the equivalent of our k squared expression. And then the second one is just n, so that would just be regular k. So I'm going to rewrite this using the Riemann-Sums formulas, just subbing in for that, times 3 times 4 over n squared. And then this is just memorization. There's no way you can figure this out. So it'd be n times n plus 1 times 2n plus 1 over 6 minus 2 times 2 over n times 2 over n times the Riemann-Sum formula, which would be for just regular k or n. I raise the first power, it would just be n times n plus 1 squared. Okay. So the next step that we want to do is we want to try and cross out as much stuff as we can. So we have a 3 here. This would give us 2, 2, 2, and this 2 would cancel out with this 2. This n would cancel out with this n. So now I'm just going to rewrite it. Now that we have our somewhat simplified version, we have 4 over n squared times n plus 1 times 2n plus 1 minus, I'm just going to multiply these two. We get 4 squared, not 4 squared. It's 4 over n times n times, nope, that n got canceled out. So it'd be times n plus 1 over nothing. So let me just put that up. And plus 1. Okay. That's the simplified version that we get after canceling everything out. So now we can just go on and distribute everything and try and get something a little bit nicer. This term, you can do it the long FOIL way. I'm just going to do it a quick way. 2 over n squared plus 3n plus 1. And then that whole term is getting multiplied by that first term. So you get left with a is about 4. So it'd be 8n squared plus 12n plus 1 plus 4. And my dog's barking again. N squared minus 4n plus 1 over 4. Okay. And I'm feeling very confident in this spot. Sorry, not over 4. I'm feeling very confident in this spot because I almost jinxed myself. Because you'll notice that this term is the same as this term, and this term is the same as this term. And that's a really good spot to be because for any of the examples that we're doing, the maximum power on the top of the fraction will equal the power on the bottom. And if it doesn't, then you should go back and you should do it again because you obviously did something wrong, at least for the first exam. Later on, I have no idea what he intends for us to do, but for the first exam, the top power doesn't equal the bottom power, you know you messed up. So then what we can do is we can take the coefficient in front of our top. So we have 8 over 1, and we can subtract the 4 over 1. Those were rules from pre-calc where if you have the exponents that are the same on the top and the bottom, what you can do is you could just divide the top and the bottom. So we get left with 8 minus 4 equals 4. And I'm feeling very confident about that, not only because I know the answer because we did this before, but I'm also going to just go through with you how to check this. And I'm sorry if this was confusing. It's a lot of work, and I'm trying to go through it quick because I don't want this to be a 2-hour-long video. And I don't want this to be a 2-hour-long video. So after I'm done erasing this all, let me just show you how to check this. In the beginning of the video, we showed the rules of how to easily find the integration. So that's actually what we're going to do. All we're going to do is we're going to integrate this function. So we're going to pull out the 3, x to the second, so it'd be 2 plus 1, so it'd be x to the third over 3, minus 2 times x to the first, so 1 plus 1, it would be x to the second over 2. These 2's cancel out. These 3's cancel out. Somebody's at my front door. That's not good. 1 second. Sorry about that, guys. I got to just finish up this really quick. So we see that that leaves us with x cubed minus x squared. And we know that we're going from 2 to 1. So we can go and we put this bar from 2 to, sorry, not 2 to 1, 2 to 0. And what we can do is we can plug in our 2 cubed minus 2 squared. And that gets us that would be 8 minus 4 equals 4. And then obviously we plug in the 0. Equals 0, and that also gives us 0. So it'd be 4 minus 0 equals 4. And that's our quick check just to see that, yep, that value matches up with that value. That's perfect. So good luck on the test, everybody. You go through this multiple times if you don't understand anything. And as always, you can always text me or just if you need something explained any further. Okay.